When should thermodynamic modeling be used instead of experimental methods? Have you ever wondered when it is better to use thermodynamic modeling rather than conducting experiments? This question is important for scientists and engineers alike. Let's break it down. Thermodynamic modeling is often the go-to choice when experiments are challenging, expensive, time-consuming, or even unsafe. For instance, if you want to study a system under extreme conditions, like very high pressures or temperatures, experiments might not be feasible. In these cases, modeling can help predict how the system behaves without the need for risky experiments. Another scenario where modeling shines is when dealing with complex systems that involve multiple components or phases. Experiments in these situations can be impractical or too costly. Modeling allows researchers to estimate properties and behaviors of materials without needing to test every single variable in a lab. Thermodynamic models use mathematical relationships to explain how factors like temperature, pressure, and composition interact in a system at equilibrium. These models can range from simple equations to advanced computational methods that incorporate a lot of data and physical principles. One specific advantage of modeling is its ability to predict properties that go beyond existing experimental data. For example, if you need to know how a material behaves at a temperature that has never been tested, modeling can provide that information. Modeling is also useful for studying phases that are hard to isolate in experiments. This can include hypothetical phases that might not exist in a lab setting. By using modeling, scientists can gain insights into these phases without the need for extensive laboratory work. Cost and time are other significant factors. Conducting experiments can be resource-intensive, and modeling can help reduce these expenses. It can also guide researchers in identifying promising conditions or materials to test, making experiments more efficient. In materials science, computational thermodynamics methods like calculation of phase diagrams are widely used. These methods help predict phase diagrams and material properties for alloys and complex mixtures. They can extrapolate data to conditions that have not yet been tested, which is invaluable for materials design. While thermodynamic modeling is powerful, it works best when paired with experimental validation. High-quality input data is essential for reliable modeling. When possible, experiments should be conducted to confirm the predictions made by models. In summary, thermodynamic modeling is preferred when experiments are limited by cost, safety, or feasibility. It serves as a valuable tool for predicting and understanding thermodynamic behavior, making the principles of thermodynamics more accessible across various fields.